see the other half here. But we have three different things. We have x-axis symmetry, y-axis symmetry, and if it's symmetric with the origin. And from a graph, it's pretty simple to see, but without a graph, I want you to know what you can look for. So if something is symmetric with the x-axis, it's imagining taking this and flipping it over the x-axis. You'd have the exact same thing down here. And for every xy, you have x negative y, whoever's phone or whatever that was, turn off. And so you can just draw that picture, or if it helps, you can write it out in words. If it's symmetric with the x-axis, if xy is on the graph, so is x negative y. And honestly, I can tell you, I like to give you this so you have it, but I don't memorize that. Like, I just think about if I flip it over the x-axis, the x stays the same and the y changes to negative. And so it's not something that you feel like probably you have to study and memorize. If you just think about what's changing when you do this. And if I'm doing the same thing with the y-axis, that would be flipping it over this way like a parabola. But for my graph I drew here, it would look something like this. And so the y stays the same on this one, but the x changes sign. So for every xy on the graph, it changes to negative xy. And think about a parabola, that's true. Like if you plug in x and negative x, you get the same thing out of it. And again, I wrote it in words, but it's up to you. And actually, I got sloppy even in my typing. I just repeated myself, right? That just means so is negative xy. But this is really the same as this. One's a graph, one's in words, depending on which way you like to learn. If something is symmetric with the origin, it's kind of like you take it and you flip it from quadrant 1 to quadrant 3, so it's kind of like this, and it would look something like this, roughly speaking. Think about that. On that one, both the x and the y are going to change, so it's going to be negative x, negative y. Back in geometry class, I think most of the time when you talk about symmetry, you just look at the graph to tell symmetry. Well, we're going to work towards how can we just do this looking at the equation and not have to graph it every time to tell if it's symmetric. And again, I feel like if you just think about it, if you know what it looks like, you don't have to memorize these. You just think about what's changing the x or the y. And so part of your homework today is we're going to say, like, test for symmetry. Is it symmetric with the x-axis, the y-axis, or the origin? And it could be symmetric with more than one of those. Think about a circle. A circle centered at the origin would be symmetric with all three of those, x-axis, y-axis, and origin. So don't think that it just has to be one. It could be symmetric with none of them, so that's why we do these tests. Everybody okay with me going on here? I feel like 100 degrees today for all you lovely kids at practice after school. Hottest day of the year, of the whole year, hottest day of the year. Today.
Is it really?
It's only like the 9th. It's only like the 9th or 10th day that we've hit above 90 degrees this year. Isn't that weird compared to last year? But it's the hottest day of the year, they said. It's only like I think yesterday they said that, I don't remember what day it was, but it's one day this week they said it was the 7th day that we've been above 90. So the day would be the 8th day that we've been above 90 like the entire year. Like we just never got to 90 like in July. It was much cooler than.
Here we discovered a new element.
I did not. What else?
It's a chemical element. It's like helium, something like that.
So now they have to change periodic table.
I don't know. I don't know how it's gonna work out.
All right, so use algebraic tests to find symmetry. If you wanted to, you could graph this to find symmetry, but I don't know about you, but most of the time I'd rather do algebra than graphing. To test for symmetry, we're just going to test each one of those rules. Test to see if the negative xy or the x negative y or negative x negative y. So I like to write it out very nicely. I think about my poor teacher grading my paper, and I want to have a lovely paper for her to be able to read and grade. And if I'm testing the x-axis, I know that it's going to flip down. So I'm checking to see if when I plug negative y in and I leave x the same, do I get back the same thing? And you're going to see as we do these, a lot of times you can just tell. You don't actually have to plug it in, but this is our notes, so I like to write it out for you. But you're checking to see when you plug this in, do you get back the exact same thing as what's there? That's kind of what we're looking for. And maybe you can tell right away, but if I plug x in here, that's still going to stay as x squared. But if I plug negative y in there, do I get back the exact same equation that I started with? No, I have a problem, right? This does not equal the same equation, which means it's not symmetric with the x-axis. That's what you're looking for. So you're looking to see when you plug in the whichever is negative, do you get back the same thing? And like I said, once you do a couple of these, you're going to see if it's squared or something to an even power, and you plug a negative in, it's not going to change. If it's not, it's going to change. And so if you don't have a lot of work to show on this, I'm okay with it, as long as you're confident in your answers. But if we were going to check the y-axis, remember that on the y-axis, it flips this way, so the x changes and the y stays the same. And so now on this one, if I plug in negative x, which I'll just show you plugging it in, but I'm not changing the y, will I get back the original equation that I started with? Yeah, because negative x squared is the same as x squared. That's the exact same thing, so I can say yes for the y-axis. And then usually you can just tell from the origin, especially because you've already plugged in a negative x and a negative y. For the origin, they both change. So if I plug in a negative x and a negative y, it can be multiple. So you do want to check them all. But I don't think this is going to work, right? Because the x is going to stay the same, but the y will change. So we get x squared plus y. Not true. So if you write it out really nice like this, I can go back and see that you said yes for y-axis. I usually either write my answer or circle it. Like, I'm okay if you go, like, I would do this. Like, y-axis works, or, I don't know. But as long as you said yes there, I guess I can find it.
So unless it's like x squared, y squared in the equation, then it's never going to be all over that.
But it could be more than one, depending on, like, some weird function. Okay? But yeah, usually it's like maybe two, but a lot of times just one. What else can we talk about today with functions? We can talk about even and odd functions. And again, we can define these as with symmetry. So an even function is symmetric with respect to the y-axis. So think about the x changes, the y stays the same. And that's what they say here. Like, if you plug in negative x, it's the same thing as when you plug in x. So I can draw my little picture again if you want. Like, here's my lovely little parabola. Symmetric with the y-axis. Good example of an even function is the equation y equals x squared. Notice that the exponent is even. It does have something to do with it. Because if the x is squared, then when you plug in a negative x, it's going to work out the same way. Also, we talk about in behavior. We'll do that later on. I don't even know if it's a chapter or not. But even functions always have arrows pointing in the same direction. Like, they're either always pointing up or always pointing down. As opposed to odd functions, look at that fancy font I used. Practice my cursive. I wonder if Miss Dawson would count that as cursive if you type the paper in cursive font. I guess. She loves handwriting. Right? Is that true? My calculus kids always practice their cursive. And my first calculus assignment is to write a paper about why you're taking calculus. It's kind of like my fun thing in the year's grade because I don't get to make papers, like written papers very often. And kids cursive because they it's skilled to have cursive writing. Yeah, I think they are showing. It's not like required to spend no time on it, but you gotta sign your name in cursive. They gotta teach you that. An odd function is when you plug in a negative, you get out a negative. So if you plug in a negative x, you make the whole function negative. A good example of that would be a cubic function, y equals x cubed. And that kind of looks like an s, kind of like this. For every x value we plug in, if we plug in a negative x value, we just get the opposite thing. And again, it's very similar to, like, it's symmetric with the origin. And again, notice, odd function, odd degree. So part of your homework today is going to say, is it even, odd, or neither? Because sometimes it's not going to be either one because there's something weird going on. So let's practice a couple of those. I went backwards on my examples on this one because I feel like this is the hardest of the examples, and then we'll do the easier one.
Is tonight's homework harder than the last one?
I don't think so. Which day we're going right, so it's a struggle. Even, odd, or neither. What you're going to do to check whether something is even, odd, or neither is you want to plug in negative x and see what happens. If you get back the exact same function, it's even, because if you plug in negative x and nothing changes, it's an even function. If you plug in negative x and you get back the exact opposite function, like the whole thing is now negative, it's odd. And if it's somewhere in between, if some things change and some things don't change, it's neither. And so sometimes you can tell just by looking. Sometimes it's kind of tricky like this one, where you have to actually work it out and see what happens. So let's see what happens when I plug in negative x for x. So this becomes negative x, and inside here I get 1 minus negative x squared. Am I going to make this a positive? No, because order of operations, I would square this first, and when you square that, it's still positive x squared. So this would be negative x times 1 minus x squared. Agree with me on that? Because it's addition and subtraction, that's why, like, you can't break up addition and subtraction under radical. Like, this is not just 1 minus x. Like, if it was this, where it's multiplication, you could say, oh, that's just 2x, because I can take the square root of 4 and the square root of x squared. But you can't do that with addition and subtraction. Like, it's stuck together. Okay? So, even function would be if I got back the exact same function that I started with. Did I get back the exact same function? No, so it's not even. What about odd? An odd function would be if I could factor out a negative and still have the same function. Could I do that on this one? Like, could I write this as negative x square root of 1 minus x squared? Is that the same as this, is what I'm asking. Like, if you just took a negative out front and then put parentheses, would those be the same? People always struggle with this, which I never realized. Because you want to distribute that negative, don't you? That's what you really want to do. That's why you're saying no? Like, you want to say no because the negative would have to go to both of these?
No, but don't you? Yeah. So it would be.
Yeah, the answer is odd here, but people really struggle with this because they think that you can't do this. It is odd. I do want to show you the difference here between, this is multiplication, that's why you can do it. Like, if you had negative 4x, that's the same as saying take the negative out front, because the negative just goes to one of those. That's not the same if you had negative 4 plus x. If you factored a negative out of that one, sorry, just a negative, that would change that to a positive, and that would change too. You see what I'm saying? And people tend to struggle with that because they want to give that negative like if it was addition or subtraction, but it's multiplication there, so you can actually just take it out front. So I just wanted to throw that one there. So this one is odd. It doesn't look odd just by looking at it, but it is odd. That was the hard one. Let's do an easier one. So, same idea. I'm going to plug in negative x, and I'm okay if you don't show a lot of work for this, but when you plug in a negative to x squared, do you agree that that's going to stay the same? If I plug in a negative to this one, that's going to change to negative x times 2, which is going to change that to minus 2x. I don't have anything to plug in here, so that's going to stay as minus 3. Even is if it stayed exactly the same, and it didn't, right? Odd would be if we could factor a negative out front, and then it would be the same. Is it odd on that one? Or another way to think about odd, did every one of these change signs? But another way to think about it. Mason.
All these you have to plug something in and just
Well, you can.
like
So what are you saying on this one? That it's even? Not even. Because it did not, everything didn't change. Like just x squared is an even function. But x squared plus 2x minus 3 is not even because it's not symmetric with the y-axis, like it's moved over somewhere, right? So the answer here is this is neither. So do you have to show me work of doing it every time? No, but don't just look at the leading coefficient. Okay? Because this changed, this didn't change, this changed, and this didn't change. So it's kind of a mix-up, like if everything doesn't change. Sometimes you can tell by looking, like if I gave you this problem, if you plug a negative in there, and this is where I'm okay if you didn't show a lot of work on this, because if you recognize that if all the exponents are even, then everything's going to stay the same. That's going to stay x to the 4th, that's going to stay x squared, and the constant still isn't going to change. So it is going to be even. Okay, but don't just look at the first one. So we have symmetry on today's homework, even and odd. And then the other thing on your homework today is asymptotes. We good with this? All right, so don't get scared by this next thing. I like to write this out, but people always get really scared by all this, right? They're like, oh, sorry, even. Because everything stayed the same. Do you agree with that?
Yeah, but so what were you trying to solve for? Like,
I'm trying to see, well, I just tried to plug in the negative x. So do you agree that this stayed the same? But if I plug in a negative x in here, negative x squared is the same as x squared, right? So it's like this one, like nothing changed. But what about on this one? If I plugged in a negative x times 2 is negative 2x. So this one stayed the same. This one changed. And this one is just a constant, so it stayed the same also. You with me on that? So if it was even, it would be like this. Nothing changes. If it was odd, everything would change. Like what if I had x cubed minus 3x? Do you agree if I plugged a negative in for that, this would change to negative and this would change to positive? So if it's odd, everything would change and you could factor that negative out. But a lot of them are going to be neither. Like they're just not symmetric with either one, so half of them change and half of them don't change, which makes it just neither. Does that make a little bit more sense? This is like the formal way to write a rational function. You don't have to write all this. I just like to show you that normally when we write a rational function, we write like this, right? Like 4x cubed plus 3x squared plus 2x plus 7. Right? We start with the biggest exponent and we work our way down. This is just a way to write that with all letters, and I just like to show it to you so you can see it's not so scary. But if you just want to write a to the n, x to the n, and then just put plus dot dot dot, I'm okay with that, like if you don't want to write this whole thing out. But I just want you to see that this is the leading coefficient. This is the highest degree, because it's important when we're doing the rules here. That's why I write it out for you. But you don't have to write every one of those. But the idea is you start with the biggest exponent and you go down by 1 all the way until there's no exponent. and they just use b in the bottom to be a different function, right? So we're totally gonna run out of time. It's just a coefficient, right? Like it's just like a is just some number. Like they're just saying a coefficient. They just use a.
Yeah, but there's actually an x, so it's called.
N just has to do with the degree though. Like the n is lowercase n as opposed like this just stands for numerator and denominator, which is not the same as this n. Like it's just a separate. Like this is just like I guess I could have used b here, but I don't know. It's not really that important. I promise. Two ways to do asymptotes. We have vertical asymptotes and horizontal asymptotes. Vertical asymptotes are the easiest because you've been doing them for a long time. You did them on your homework yesterday when you were doing domain. You just set the denominator equal to 0. Set denominator equal to 0 and solve. The other type of asymptotes are horizontal asymptotes. And if you remember, the reason I wrote this up like this is it's all about the degree of the numerator and the degree of the denominator. And there's rules for this. And if we don't get through all this, I will put the rest of this up, or you can just look in your book because it's there. But there are different rules here, whether the degree of the numerator is bigger than the denominator, smaller, or equal to the denominator. And as we do this, it should maybe jog your memory a little bit. And this is where the n and the m come from the degree of the numerator and the degree of the denominator. So that's why I wanted you to at least write like this part of this problem. If the numerator is less than the denominator degree, then your horizontal asymptote is always the x-axis, like 1 over x, which we graphed yesterday. It's always the line y equals 0. If the numerator degree is equal to the denominator degree, that's where you take the leading coefficients. So that's where this comes from, right? You take the number in front. So it could really be any number, because it's just whatever the leading coefficients are. And then the last option is if the numerator degree is bigger than the denominator, there is no horizontal asymptote. And at some point this year, we'll remind you that there could be a slant asymptote. We'll do that, but not today. So if the numerator is smaller, it's y equals 0. If it's equal to, it's the leading coefficient. And if it's greater than, then there's no horizontal. So there's a few questions on your homework today, and we'll do this tomorrow as well, see how it goes. It's the end of your homework that asks you to find all asymptotes. So I had a couple more examples that I'm not going to get to. But try those tonight, and we'll start with this tomorrow. We just have a worksheet tomorrow anyway, so it'll be good to start with this and kind of finish up. But if you use these rules, it's really not the worst thing in the world to do. Are you done writing that? The assignment is the same that's on your assignment sheet. Let's see if I can find that if you don't find it. I believe you're doing 48 through 62 even, and 74 through 76. That's page 103, 104. You shouldn't have to graph to find your asymptote.
I know we're going to not get it, but
And again, we'll pick this up tomorrow.